Okay, complex fractions. You need to simplify complex fractions today. That's our goal. In order to simplify complex fractions, the first step is to create one fraction in the numerator and denominator. So I rewrote this as 1 over a minus b over 1, divided by 1 over b minus a over 1. We all good with that? Okay. What do I have to do to create one fraction in the numerator? How? Yeah, multiply top and bottom by a. So now you can see that in the top, I have 1 minus ab over a. What do I do to create one fraction in the denominator? Top and bottom by b. So I get 1 minus ab divided by b. Anybody know the second step? Multiply by reciprocal. That's how I show my work. See, the 1 minus ab's will cancel. And you get b divided by a. So the third step is to cancel and simplify. Is that straightforward enough? Okay. In order to do calculus, you have to be able to handle complex fractions. Again, the course is pre-calculus. The things that prepare you to do calculus. That's what most mathematics actually is. It's just to be able to get you to do calculus someday. Be sure ashamed to do all these years of mathematics and then never do calculus, right? I mean, that's kind of the big goal, to be able to do that and see it through. So here we go. 1 over x minus 1 over c over x minus c. I'm going to rewrite this as 1 over x minus 1 over c over x minus c over 1. So x minus c over 1, that's the fraction in the denominator. What will I do to the numerator in order to create one fraction now? X over x, very good, Alex. This one by c over c. So what do I have? So minus x over cx over x minus c over 1. Multiplied by the reciprocal, which is 1 over x minus c. Can I cancel off the c minus x and the x minus c? So what do? Carson is correct. We take out a negative 1. If I factor a negative 1 out of c minus x, what do you get? You get a positive x, and you get a minus c. Everybody stare at that. Make sure you got that. When I factor out a negative 1, the c changes to negative, the x changes to positive. You all got it? Over cx times 1 over x minus c. Now you can see that the x minus c's will cancel. We get negative 1 over cx. Now, normally I won't show that in my work. What I will do is I'll say c minus x and x minus c are the same. They just differ by a factor of negative 1. So I'll just pull a negative 1 out. And, you can just make any term negative then, and that's enough. So that's how I generally show my work. Good? Okay, you're doing well. Good job. We'll do 3 and 4 and 6. We will not do 5. You'll have a lots of time to work. 1 over 3 plus h. minus 1 over 3 over h over 1. What to do, what to do, what to do. Very good. 3 plus h. 3 plus h. Good. What are you left with in the numerator? Okay, 3 minus the 3 plus h. What is 3 minus 3 plus h? Close. Look at it, folks. Look, you get 3 minus 3 plus h, right? What's 3 minus 3? 0, but you have to distribute the negative to the h, and you get negative h over 3 times 3 plus h over h over 1. Now we multiply by the reciprocal, which is 1 over h. You can see the h's cancel. Negative 1 over 3 times 3 plus h. You guys did these last year a little bit, right? Okay. No. It's important stuff. That's why we, so really the section on fractions is both yesterday and today. We take 2 days on it. Yesterday was kind of the easier review. Today is a little bit more difficult. All right, 2 more. A plus h over a plus h plus 4 minus a over a plus 4 over h over 1. What am I going to multiply this by? Yeah, there's no easy way around it. And the other side by a plus 4. A lot of times people don't want to do it. They're like, there's no way that the problem can be that lengthy. We do a problem in calculus like this. It takes up all 5 boards. So sometimes the problems really do take up a lot of room. We'll be able to finish this one off in a few steps, but it is a little bit more work than the others. A plus 4 times a plus h. A squared. AH. 4a. 4h. Minus a squared. Minus AH. Minus 4a. All over a plus 4 times a plus h plus 4. All over h over 1. What do you notice? Yeah, it's like Christmas, huh? Who needs a new homecoming dress? You just do a cool math problem. That'll make you happy. Gone. AH, gone. 4A, 4A, gone. What's the only thing that's left? The 4H. Now, this is what I want you to understand, because these problems, they start to develop kind of a pattern. Does everybody see that when I multiply by the reciprocal, what's going to happen when I multiply by the reciprocal? I'm going to get what? Yeah, the h is going to go into the denominator, right? Does everybody see that? So sometimes instead of showing that piece, I just, drop the h right down there. Does everybody see how that just works out real nice? So now the only thing in the numerator is a 4h. So that's written in factored form. So what's going to cancel now? An h. The h is gone. We get 4 over a plus 4 times a plus h plus 4. Good job, folks. You guys are getting smarter. You see, in a lot of the review we do, it's just reinforcing what's already there. But when we do things that are somewhat new to you, you start to build connections and you literally get more intelligent. You literally build brain cells. Like you can't say that all the time in every class, can you? Like if you're doing things in class that simply just require you to regurgitate information, that just pulls from one side of your brain. Whereas when you're doing processes and you're seeing connections, that uses both parts of your brain and you get smarter. Good for you. Okay, we're going to skip number 5. We do number 6. Here's the big mistake that people make for number 6. They take this x and negative 2, they drop it down. This x and negative 2, they pull it up. This x and negative 1, they drop it down. You can't do that. It's not written in factored form. So what you have to do in this situation is write it as such. This is 4 minus 4 over x plus 1 over x squared. So knowing what I just told you, could you please tell me what the bottom is going to look like? Very good. Alex is on fire today. He ate his Wheaties for breakfast. Good job. Is Wheaties still a thing? Like, can you eat Wheaties? They are. Frosted mini Wheats. Those are not Wheaties. But I love some Frosted mini Wheats. Same thing. Oh my gosh. All right. Cool. So what am I going to do to create one fraction in the numerator? Good. X squared over x squared. X over x. We all good with that? Excellent. So now I'm going to write that fraction. Some 8th graders running around there acting like 5th graders. Got to make sure they're not breaking anything. 4x squared minus 4x plus 1 over, what's the denominator? X squared over 4x squared minus 1 over x squared. Have you guys learned now, have you seen the pattern that when you have a fraction over a fraction and the denominators are the same, that they will eventually cancel? Okay, that's good news. So that's part of what you want to be able to anticipate, is be able to look ahead and anticipate what might cancel, what might happen. So you see here as we multiply by the reciprocal, sure enough, the x squareds are gone. Wouldn't it be nice if 4x squared minus 4x plus 1 factored? It does? Well, I've got 2x and 2x. Minus 1, minus 1. And then Shelby is correct. She was factoring the bottom. 2x minus 1 and 2x plus 1. And sure enough, the 2x minus 1's cancel, leaving me with 2x minus 1 or 2x plus 1. And then we all know these are gone, and negative 1 over 1 is negative 1. No, folks, that's totally illegal. Come on. You're supposed to yell at me when I do that. Can't do that. You were freaking out. You're like, okay, I'm done. Like this guy, like he just broke every rule he talked about yesterday. No, you can't cancel us off. Shame on us. It's okay, you can laugh. I'm a funny guy. Not just funny looking, funny guy. I'll say hi, YouTube. No. Oh, I'm scared of the microphone. All right, very good. Here we go. We'll get your